This sequence is called a linear sequence because the numbers increase by a fixed amount each time. When we look at a sequence of numbers, we have to remember that each sequence of numbers has at least two other sequences of numbers associated with it. One of these other sets of numbers is known as the term, and the term indicates where in the sequence a particular number is placed. For example, this is the fourth term, and the value for the fourth term in the sequence is 7. This is the fifth term, and the value for the fifth term in the sequence is 9, and so on. Another series of numbers that are associated with a sequence of numbers are known as the pattern. The pattern of a sequence is identified from the value of the difference between two adjacent numbers in the sequence. The pattern in this sequence is +2, but it could be any positive or negative number. So starting from the point of having a single sequence of numbers, we now have three sets of numbers: the sequence itself, the terms, and the patterns. From the relationship between these three sets of numbers, we can form what is known as a rule, by which any number in the sequence can be calculated. And this rule is called the nth term. Basically, forming a rule by which we can identify any number in the sequence is a two-step process. We take the pattern number, multiply it by the term number, and add or subtract a value to arrive at the number in the sequence. An equation for this rule would look like this, where un is the value we are seeking, a is the value of the pattern, n is the position in the sequence, and b is the value we have to add or subtract to arrive at the number in the sequence. Look at the first number in this sequence. The pattern between the first and second number is +2. The term for this number has a value of 3. Our job is to identify the relationship between the pattern, which is 2, the term, which is 3, and the sequence number, which is 5. We can see that if we multiply the 2 by the 3, we will get 6. 6 is 1 too high, so we have to subtract 1 from this to arrive at the number we are seeking, which is 5. We can then place these numbers into our equation and get u3, which is the value we are looking for this number in the sequence, is equivalent to 2 multiplied by 3 minus 1. We'll just review what we have done here. We have taken the pattern value and multiplied it by the term value. This gives us a number which is too high, so we have to adjust this number. We subtracted 1 from the 6 to arrive at the 5 we need. We can rewrite our equation into a general rule by which we can calculate the value of any number in the sequence. And this general rule is un equals 2n minus 1. Say we wanted to calculate the value of the 54th number in the sequence. We could write this as u54 equals 2 multiplied by 54 minus 1, or u54 equals 107. Therefore, the number in the 54th position in the sequence would be 107. Remember, to identify a rule for the nth term in a linear sequence, we multiply the pattern by the term and then add or subtract a value so the end result matches the existing number in the sequence. Once having identified a rule for the existing numbers in the sequence, we can then use this rule to identify the value of any number in the sequence.